Hello, this is Ali Kotami with SCS Engineers. Thank you for taking time out of your busy schedule and listening to this presentation. The subject of this presentation is use of Geogrid in landfill lining systems. Geogrid is used in many different civil engineering structures. Primarily used for adding strength to soils that need additional strength depending on the loading in the structure above the soil. Also for supporting surcharge loading above less stable subgrades. It could be many different cases if the subgrade is a soft clay that has very low level of strength, or it's a organic soil that doesn't have much shear strength in it, so Geogrid can be used to provide additional strength as the foundation. Also forming soil Geogrid composite structures. This is primarily for systems that are used for soil erosion or coastline protection projects. Many different industries use Geogrid in their structures. A number of them are stated here: airport, mining, oil and gas, rail, residential, roads and highways, waste management, and wind farms. And there are many cases that under each one of these industries that the Geogrid was required to strengthen the system that was under construction. There are many other industries also using Geogrid for one reason or another, which are not listed here. A few applications of Geogrid: road-based stabilization. It could be highways or small two-lane roads, and even the airfields for airport, for airplane landing. Retaining walls and slopes are another example of use for Geogrid. MSE walls or roads and landfills for roads and landfills. We have seen cases of MSE walls for landfill expansions that Geogrid is used extensively in them. Foundation reinforcement for above ground structures. If the foundation is not stable enough for the structure, they add Geogrid to it. Erosion control systems. I mentioned earlier that a soil Geogrid system is used for erosion control, or coastal protection system for the same reason. If construction is taking place over soft foundation, Geogrid gets used to strengthen the foundation. And the last one, construction over less stable foundation. This is what especially comes to mind, is lateral expansions to landfills, that the lateral expansion section overlays the old landfill. The old landfill may not be stable enough to hold the weight above the slope, so they use Geogrid to strengthen the slope below the new lining system. Location of Geogrid depends on the application of the Geogrid and the soil layers. Geogrid could be within a soil layer, like in between different lifts of the soil layer can be installed, or it could be at the interface of two adjacent soil layers. The reason for it is that the Geogrid has openings in it, that the soil particles from below and from above go into these openings, and they kind of create a structure between the soil particles and the ribs of the Geogrid, which strengthen the shear capacity of the soil. The subject of this presentation is use of Geogrid in landfill lining system application. This is specifically a case that is related to Citrus County landfill in Florida. The landfill or this section of the landfill was designed by the SCS, and Mr. Ed Hilton was the designer and the engineer record for the design. The design credit goes back to Ed Hilton. This lining system has steeper slopes, like a 2-to-1 slopes, and there are 2 geogrids involved in this lining system. One geogrid is above the subbase soil and below a texture geomembrane, and the second geogrid is above the composite and below the sand layer. The lining system geosynthetics from bottom to top are arranged as a geogrid goes in first above the subbase or the base layer. The texture geomembrane above that, geocomposite goes above the geomembrane, and the second geogrid goes directly above the geocomposite. Now I'm going to show you a number of pictures that from the site. These pictures come from a recent project was done at this specific cell that was constructed many years ago. It's not active yet, no waste is placed in it yet. But a fire kind of started at this location and damaged the lining system geosynthetics that were constructed some years earlier. So I'm going to show you where that was, and the repair work needed to be done. That SCS staff was present on site doing CQA on the repair of the geosynthetics. The slope that you see in front of you in the background of the slide is the intact slope. No damage came to that slope. But the slope that you see in the foreground of the slide is the damaged area. You don't see the damaged area in this slide because they pulled a kind of a plastic sheeting over the damaged area and held it in place using tires and the ropes. But when they came to repair the lining system, the tires were removed and the plastic sheeting was removed. That is shown on the next slide. Here is the damaged area after removing the tires and plastic sheeting. You see this is the geosynthetics, which were 4 layers, and as I explained earlier, completely burned out, and the subbase is exposed as you see in this slide. In the foreground you see the lower layer of the geogrid exposed and visible, and I'm going to take you one step at a time through the repair process. This view shows the repair area. A little bit of explanation here where the actual repair area is in this picture. To the left side you see that white color area, that is the sand layer on top of the riser pipes that you see at the top of the slope. Geosynthetics of the lining system were below the riser pipes, and the sand layer above protected the geosynthetics in that area from the fire. But to the right side of that sand area, which is more an area with a tan color, is the damaged area. This area is bounded by 2 lines extending from the top to the bottom. The right side line has a black area to the right side of it. That is the existing geomembrane in the lining system that didn't get damaged. So there is a boundary line of fire damage in that area. To the left side of the tan area is a line that extends from the top to the bottom. That's also the other side of the repair area. So primarily the tan color area is the repair area for the geosynthetics. As you see here, they are cutting the excess material in order to create a new edge for the geomembrane. The geomembrane that you see in this slide is the original geomembrane that was not impacted during the fire event. Geogrid is below the geomembrane, is visible. Parts of it are, the burnt pieces are still there, that's being handled. They're going to cut back the geogrid also to the line of cut in the geomembrane, in order to prepare the area for repair. Here it shows the geosynthetics to the right side of the repair area where the stakes are. They have cut back the geomembrane and the geogrid to expose the soil below it. To the left side of the repair area you see the cut line in the geosynthetics and the stake marks. So the area in between the two stake marks extending from the top to the bottom of the slope is the repair area. New geosynthetics are going to go in and tie to the existing geosynthetics on the two sides of the repair area. They start with bringing soil, pushing soil over the slope in order to regrade the slope for installation of the geosynthetics. In this slide, the soil is already placed and graded, and the area is ready to receive the first geosynthetic layer, which is a geogrid. Here the geogrid installation has commenced. To the left side is the 2-to-1 slope going down, and geogrid is extended over the 2-to-1 slope. To the right side you see a deep anchor trench for the geogrid. Here is the anchor trench for the geogrid. When you use geogrid in the lining system, the anchor trench plays a significant role in keeping the system in place, because the interface friction angle between the geogrid and the geomembrane that goes on top of it is not significant, meaning it has a low interface friction angle. So the only thing that will really play a substantial role in holding the geosynthetics on the slope is the anchor trench. That's why the anchor trench is so deep, in order to make sure that it has sufficient holding capacity for the geosynthetics going into it. Geogrid panels get installed and they get tied together with using plastic ties. Then the geomembrane panels go in, and the geomembrane is a textured geomembrane, and the smooth edge of the geomembrane panel is visible here in the foreground. It's about 8 inches of smooth for welding two panels, adjacent panels together, but the majority of the surface of the geomembrane is textured, and it goes directly above the lower geogrid. Geomembrane gets anchored in the same anchor trench as the geogrid at the top of the slope. Then the fusion seaming connects the adjacent panels, seams the adjacent panels. Pressure testing is done on the fusion seams. Repairs are done, patches are installed, grinding of the extrusion weld area, it takes place first, and then extrusion welding takes place. Basically, these are the few steps that we go through in order to complete the geomembrane work, and then the vacuum testing takes place on extrusion welds. After the geomembrane is complete, then they pull the geocomposite panels over the geomembrane. This is a double-sided geocomposite that gets pulled over the geomembrane. It gets anchored in the anchor trench at the top of the slope and extends all the way down to the bottom of the slope to tie into the lining system at the bottom of the disposal cell. The panels are tied together using plastic ties, and the geotextile components get sewn together. As I indicated earlier, the geocomposite goes into the anchor trench at the top of the slope. This is a view of the repair area after completion of the geocomposite. Geocomposite is tied to the existing composite at the bottom of the slope, and anchored in the anchor trench at the top of the slope. At this stage, the backfilling of anchor trench begins. So we have 3 geosynthetic components go in the anchor trench before the backfilling begins. The lower geogrid, the texture geomembrane, and the composite. And the backfill gets compacted using either the hand tamper compactor or the back of the backhoe bucket. In this picture, it shows that the anchor trench is completely filled, where the guy is standing with the shovel in front of it. Was used to be the anchor trench that's completely filled to the top of the anchor trench. Now the small machine is creating a new anchor trench for the upper geogrid layer, because they wanted to secure the upper geogrid in a much larger anchor trench that would make it independent of the previous anchor trench. This is the larger anchor trench that's being excavated. The previous anchor trench is right at the edge of the geosynthetics to the left side of the slide, almost where the guy is standing with the shovel, is the old anchor trench. After the anchor trench is formed and everything, they start installing the second geogrid, which is directly on top of the geocomposite. The geogrid panels get tied together using plastic ties. At the top of the slope, geogrid goes into a larger anchor trench. This larger anchor trench is the one that was being formed in an earlier slide. A significant length of the geogrid is extended into the larger anchor trench for the purposes of increasing the surface area, contact area of geogrid with the backfill that's going to go over the geogrid in the anchor trench. The higher the surface area, the higher holding capacity of the anchor trench. Significant design considerations needs to be made to the design of the anchor trenches for this type of applications that has geogrid in them, because the slopes are steep and the interface friction angle between the geogrid and adjacent geosynthetics are fairly low. Here it shows the repair area completely covered with the second geogrid. Geogrid gets connected to the original geogrids on either side of the repair area and gets anchored in the larger anchor trench at the top of the slope. Then, since this cell is not going to be placed in kind of active mode or an operation, they're going to cover the geogrid with a plastic sheeting like other areas, other slopes, and then and secure the plastic sheeting. This is the plastic sheeting over the repair area, and then they would add a ballast load on top of it in order to keep it in place. After completing the plastic sheeting and securing it, the project gets pretty much completed. They had to do some pipe work on the riser pipes that I didn't present in this presentation because it was outside the scope of what we wanted to discuss. But the fire damaged the upper part of the riser pipes, a couple of them. They cut back the damaged section of the riser pipes, they added a new section to it and did the replumbing of the pipes and everything. But it's not shown in this presentation. Couple of comments. Low interface friction angle between geogrid and adjacent geosynthetics requires a significant anchoring at the top. The anchor trench plays a substantial role in keeping the geosynthetics in place. The type, the size, the surface contact area, backfill compaction level, moisture content, and interface friction angles are important factors in the design of the anchor trench. With that, I conclude my presentation. I thank you for taking time out of your busy schedule listening to this presentation. If you have any questions, please don't hesitate to contact me at 561-441-1473, which is my cell number, or you can reach me on my email address at akatami@scsengineers.com. Thank you.